Okay, so toroidal space, right? Okay, how can I describe? All right, okay. Time is relative to speed and density. Just to explain, this is the basis of the fundamental principle at the basis of Einstein's E equals mc squared, which simply put means that energy multiplied by the speed of light equals matter squared. Okay, so basically, if you take a lump of matter and square it, then the resultant energy will be E times the speed of light squared. I may be slightly wrong with those maths, but that's basically it's an equation that comes out with very big numbers, which is why a small amount of plutonium makes a very big fucking bang when you liberate all of the energy contained within it. Right, okay. Somebody asked earlier, I think it was Paddy again, how small a particle are we thinking of here? Okay, well let's think first of all of an atom. Okay, an atom is essentially equidistant between a planet and a sun. Okay, so an atom is the same proportions as the sun is to the Earth and the Earth is to an atom. So we're looking at quite relativistic proportions here. And that if we were to take a picture, could we take a picture of an atom and put it on a computer screen? That computer screen will be made up of thousands of pixels. Okay, the points that describe the shape of that atom would be fractions of a pixel. Okay, that's how small we're talking. Okay, so the star tetrahedrons that I'm asking you to consider this matrix to be made up of are tiny hundreds of thousands, if not millions, of a point on something that is a few millionths of the size of the planet. Okay, so a few billionths even. Vastly small. But don't be put off by the ridiculous insignificance of such small things, because exactly the same is reflected in the galaxies. What we see in a galaxy and a solar system are just simply fractal extrapolations from the shape of the atom. We're seeing exactly the same nodal frequency points. If you look at a galaxy, what you're seeing there is the shadow left of the exported energy field from the star tetrahedron that underlies the fundamental shape, and this is borne out by the relativistic distances in spatial objects and the relativistic sizes, that things like the size of a planet and the size and number of its moons are borne out within the mathematics of the star tetrahedron. The distance of the planets from the sun that they orbit and the size of the sun are relativistic proportions that are maintained throughout the star tetrahedron. So what we're seeing is you have to consider the kind of the star tetrahedron that underlies this as possibly being a hyperdimensional object beyond the three dimensions of length, width, height and time, into some implied dimension that we are not witness to. Certainly all of the scientists agree that there are more than four dimensions, the three dimensions of space and the one of time. Just a little point there, my personal experience of a herb called Salvia divinorum is the hyperdimensional herb. It facilitates the ability to experience the hyperdimension, the hyperverse, directly, and takes you to some very peculiar places. Right, okay, yes, there's a mathematical formula to the design, Paddy, and it's the Fibonacci sequence. If you go looking into sacred geometry, you'll find the Fibonacci sequence, which is a very simple mathematical sequence. It's basically 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so it goes on. And when you look at near enough everything in nature, it responds and corresponds to this Fibonacci sequence. What I'm suggesting is that what we're actually seeing with the complexity of the universe is the interaction of multiple Fibonacci sequence-driven fields engaging with each other and creating the complexity of interference patterns that present themselves as all life to us. If anybody wants to look into it, you'll find that the famous Leonardo da Vinci painting of the man with his arms outstretched and above his head and with his legs together and split out is actually drawn in two primary circles, and illustrates quite clearly how the entire shape of the human being is described by the star tetrahedron. It also, within the lines contained within that drawing, he also finds the line which describes the thickness of the cell wall. And this is fascinating because the cell wall wasn't discovered for at least 100 years after Da Vinci was working on that drawing. So he basically had the numbers there to construct the universe within the geometries of that particular drawing. Right, okay, yeah, golden ratio, phi, basically 1.1683. It's like pi that we're all taught at school, but this is the one that we're not taught, okay? Pi is 3.14. We use it for calculating the circumference of a circle from any given radius or diameter. With phi, it's a lot more subtle. Phi is the proportion that your sheet of A4 paper performs to. The height of a sheet of A4 paper is a direct phi relationship with its base. So it's 1.683. Sorry, 1.1683. Thank you, Pondy. I should know that because my mate Phil goes by the name of 1.1683 on Skype and on all the chat boxes. Okay, essentially this describes the ratio of all organic shapes. So our span, the distance between our fingers when our arms are outstretched, is a phi relationship to the overall height of our body. The length of our forearms is a relationship to the length of our overall arm length, the length of the components of our fingers. These are all direct phi ratios that hold up to within tenths of a percent of true to phi. Yes, it really does promote good health, and not only that, the concept of the morphogenetic field, this field that describes your natural cellular shape. The closer you can reflect your true morphogenetic field, stand up bloody straight, put your shoulders back, concentrate on your posture and keeping your body in the alignment that it was born to hold, and suddenly you'll find that your health will improve, your mood will improve, your general kind of sense of the universe will immediately brighten. So... Okay, Pondy, you know the bloody maths. Like I say, I came out of comprehensive school with, oh my God, like a D in English. I think my maths paper was laughed out of the room. Technical drawing, metalwork. I made it without going into the army or Ford, so that's something to be achieved from having gone through a fucking school like that. Fucking torn it down now, turned it into a bloody college, thank God. Paddy, I'll chuck a few links out at the end of the show. It's just I'll be rattling away on the typewriter otherwise. So what we got now? I'll tell you what. Yeah, look, I'll chuck a tune on and I'll sling you a couple of links for later. What should we have? Let's have something a bit more funky. Let's go for Slackababa, Dubterrania. This one will do. Twist your heads around this one, guys. You gotta love Terence McKenna, haven't you? He's the voice of psychedelia. That was Slackababa, Dubterrania. Right, we've got to grapple really with time. Time isn't as simple as we feel it. Okay, I was going into relativism. Alright, because time is relativistic to nearness to density, nearness to a dense object, and also the speed through time-space relativistically affects time. So to the point of the observer, the person travelling at light speed across the universe, is aging much slower, or their clock would appear to be ticking much slower than the observer's clock, even if the two clocks were identical. This is the lensing, the distortion of time due to speed and density, mass and speed, basically. So here there we have the E equals mc squared part of Einstein's equation. So essentially, we are in a rotating galaxy. That rotating galaxy is moving through time-space. Okay, we are heading in a collision course, supposedly, with I believe it's the Alpha Centauri galaxy. But essentially, if you imagine the galaxy being like, say, a frisbee or some helicopter blades twirling their way on the top of the helicopter, and the helicopter has a forward motion through time-space. Now, the effect on the helicopter rotor blades is an interesting one. There's a reason why the Lynx helicopter currently still holds the world record, even after some 20-odd years, of about 246 miles an hour. And this is down to the speed of sound at the tip of the advancing blade being the limiting factor. Some clever blade design was all that managed to get them up that high, and nobody's really managed to replicate that since. I think they basically buy Lynx's brand of helicopter blades if they want to do something similar. Okay, so we have this advancing and retreating blade. Now let's consider this. The helicopter's moving forward. Let's use simple numbers. So let's say the helicopter's moving forward at 250 miles an hour. Okay, so we have an airspeed, or in this case a time-space speed, of 250. Now, the helicopter rotor blade is spinning through the same air or the same time-space as the helicopter is advancing through. So the tip, as it circles the top of the helicopter, one blade is advancing and one blade is retreating. The advancing blade has, at its apogee, at its most tangential at 90 degrees to the helicopter, it has its own speed of rotation plus the entire forward motion of the helicopter as its speed through time-space or through air. The retreating blade has the speed of the helicopter forward through the air minus its own rotational speed at the point of apogee. Alright, okay, so essentially we have one rotor blade that is, let's say it's spinning at 500 miles an hour at the tip. Then at the 9 o'clock position, it will be travelling at 750 miles per hour, and at the 3 o'clock position, it will be travelling at 500 miles an hour minus 250, which would be 250 miles an hour. So you can see we've got a 500 mile an hour differential between the two blades. Now, because speed affects time, what we'll actually be seeing there, if we could see time like it was air, we would see that the density of time that one blade was having to move through would be much, much denser than the one that was retreating. And if we could actually imagine time like the air being corkscrewed out of the helicopter blades, then what we would actually see is a torus being formed, a torus